So usually at these meetings, what we try to do is to give everybody a solution they can take home and implement and do to keep it all together. So I kind of put together a little bit more of a solution to all this. So what I said was revive to stay alive, reverse climate change now. Because when I was, it was kind of interesting when I was running for mayor and I was sitting there at the discussion forums and the question of climate change came up. Pretty much everybody in the leadership thought climate change was inevitable, and the solutions proposed were to build the roads higher away from the ocean and to do to basically put your head between your legs and kiss that part of your body goodbye. I was the person up there saying, look, we got these solutions, we got them, they're right here, they're at our feet, they're on you, they're all around us. It's a matter of concentrating them a little bit. It's a matter of food, good food. Who enjoyed the food?
So good.
Yeah! Thank you for the food. It was epic. I really enjoyed it. And it's about knowing what's going on. So it's actually a pretty simple thing that's happening to our world. So I got 3 ultra low cost solutions, and those are life, food, and minerals. And so if you're a natural farmer, you've probably heard some of this, but essentially microorganisms stabilize our climate. So what they do is their bodies go into the soil and they turn into the second largest carbon sink. I think the first largest carbon sink is the ocean, and the second largest carbon sink we have available to us is the soil itself. Of that amount, according to the article I was reading to kind of do a little bit more research on this, about 25% is in trees and things, and 75% can be in the soil. But I think even more can be in the soil. One of the largest carbon emissions we have today that's not really even talked about is when we strip these pieces of land and we bare them, tons of carbon off gases and goes into the atmosphere. So we think it's all from like cars and burning hydrocarbons, but it's actually from our agricultural practices as well and the way we do vast land management. So when we have a nice forest and we cut it down to put in grass, we're actually emitting a ton of carbon that could have been stored in that system. The microbial rich soil prevents erosion and holds in moisture in the soil. The microbes' bodies are full of water, just like you and I are full of water, and they actually hold moisture in the soil. And then the microbes feed the trees and cultivate forests and natural ecosystems, which then can sequester even more carbon and reverse what we consider greenhouse gases to be causing global warming and those types of issues. And like I was talking about the water being pulled out, when that happens, it actually cools a little bit. So the microbes can cool the soil. Microbes can also cause or prevent plagues. Like you get sick from microbes or healthy because of microbes. And it's my personal belief that lactobacillus is responsible for mammals' dominance on Earth today. So we are mammals, we produce milk through mammaries. Lactobacillus's favorite food is lactose, which is highly prevalent in milk. So I'm pretty sure they're farming mammals to keep them alive, to make them the dominant species so they have more of their favorite food. So microbes play a huge role in not only the soil, but also the life and everything above this.
Did you just say that the microbes decided that they will leave mammals on Earth so that it could eat its favorite food?
Yes.
Oh.
Lactobacillus is 1 in 3 microorganisms are lactobacillus. It's the most dominant. It's a super broad family, and I believe it's farming us.
I see.
So lactobacillus is the way.
That's the way.
So partnering with these things, instead of just killing them and recognizing their prevalence in our life and everything, is my premise for how I'm talking about reversing climate change. We understand what they do for our environment, what they do for us. It makes sense to make friends with them. So essentially we have 3 recipes. One of those is life. And this life recipe is super simple. We've been talking about, in natural farming, we talk about indigenous microorganisms. And just recently we learned from Young Song Cho, the son of the person who kind of got all this started in Hawaii, that it's really low cost to make these microbes. So what you need is a 5-gallon bucket. It's pretty easy to get. And it can be any size container. I'm just going to give a 5-gallon recipe because that's what makes sense for me right now. You fill this up with 4 gallons of fresh water. It's best to get this rainwater, but like I was saying, you can take water and introduce some microbes to it to make it living water, like we were talking about. Use straight chlorinated water, it's not going to be as beneficial for you. After you fill it with water, you cook a potato, just boil it. You can use sweet potato, you can use ulu, you can use any starch. This potato I'm holding in my hand happens to grow the microbes the fastest. Other starches will grow microbes at different speeds. This one, they love to eat this starch, so it grows really fast. You boil this, you need about half of it for the 5-gallon bucket. Then you go down to the ocean and get ocean water, or if that's too heavy for you, go get sea salt. It's pretty inexpensive to buy. Make sure it's actual sea salt. And you need 4 teaspoons of this. So for every gallon, or tablespoons, it doesn't really matter. It's pretty broad on your spectrum here, but 4 spoonfuls of salt. You want to get the same salinity as your blood. So you can go look that up if you want, but the way I do it is I just take 4 nice spoonfuls and put it into the water. You dissolve that really well. You've now made seawater that's diluted 1:30. So if you actually gathered seawater, you could just dilute it 1:30 in there. But sometimes it's easier to use sea salt. It's a lot lighter. And then you need a handful of microbial rich dirt. So go under your favorite tree where a lot of leaf litter is accumulated, or if you don't have that available to you, take a bunch of leaves, make a big pile of them, come back in 3 or 4 days, you'll notice the dirt turned into these little tiny balls where it's balled up. That dirt has all kinds of IMO in it. And it's that very top layer. You're gonna get the top less than 1/4 inch of dirt that has this super rich microbial dirt. Gather enough of a handful, about the same amount as the potato, and mix that in the water. You can put the potato in a bag, in a sock, and put the leaf, the dirt you gathered in another sock and kind of massage them into this salt water that you've created. Or what I've been doing lately is just throw it all in the blender, turn it on for a couple minutes, and then just pour it in. You still get microbes to grow. They still do their thing. The idea is to mush up the potato into the water and mush up the dirt that you've gathered so that they mix really well into the water. So you're feeding the microbes Gatorade through the salt and putyi through the potato and the starch. So if you're going to go into battle, you need starch and Gatorade, and you're good to go. Same with these guys. You give them the essential foods they need, and essentially what you get in here is just trillions and trillions of microbes that grow within the next 24 to 48 hours. It's safer to get it on the way up, so sooner than later, because eventually these microbes will eat out all the oxygen in here, and then they'll start to die. When it's good to use, it should smell kind of good. It shouldn't smell stinky. If it smells stinky, it kind of went too far. After those 24 to 48 hours, you got your microbes now. Then you want to dilute them with fresh water. about 40 gallons I find here in Hawaii is about what it is. So I do about a 10-to-1 thing. So I have my 4 gallons of water that now has all these microbes growing in it, and I mix it into 40 gallons of water, and then I spray that around. The extra liquid helps them, they're like fish, helps them establish themselves into the soil. So you've made trillions and trillions of life, you got to give them a way to get into the soil. And like I was talking, the further they penetrate down, the more they're going to bring oxygen, the more they're going to start to sequester carbon into those areas and build life in your soil. So we actually, Arthur made that, and it's outside here. So after this, you can go check out, see the real deal. It's bubbling, right?
Yeah.
So you'll see the bubbling effect, and these bubbles are caused by the microbes growing in there, and as they grow, they bubble, and they get to vast numbers, and you can take it and put it under a microscope, and you see all kinds of stuff zooming around. So that is how you get the life into the soil. But if we just have life, it's not quite good enough, because if we have all of us here and we have nothing to eat, we're going to get aggro, which might be good if you think of it as agricultural. But we also need food. So this is so easy, a 6th grader can do it and describe it. So I know it's a little bit hard to see, but I'll read it to you what he wrote. He said, first we picked all of the weeds, then we put it in a bucket, then we put water in the bucket, then we put handfuls of leaf dirt in the bucket and mixed it. So go get any and all the weeds, the grass, the junk stuff that's growing around your house, cut it, put it in the bucket, pack that thing full, fill it with water. The same leaf mold that you were gathering, the IMOs, that you gathered for the first recipe, gather that same thing, about a handful of it, mix it in, and then stir it around. Those microbes will start to break down the grass. And in about a week, you have a really good food. This, to use it, you want to dilute it about 1 to 100. And also be careful to try not to get it too much on your skin. It's really stinky. But the stinkier the better, I'm told. So don't worry about it. Mix and that can be mixed into that 40 gallons that you're going to put the life out with. So I didn't write down the exact ratio of what that would be. So got life, we got food. Any questions so far? The third thing we need is minerals. I have a theory that there is a microbe behind every mineral. So when you're actually seeing minerals, they're fossilized microbes. I don't know if it's true or not, but it's something I've been exploring. So when you go down and you go to the seawater is full of minerals. So when you gather these ancient fossilized minerals from the ocean and you mix them with your microbes, they then, and the food, they reanimate and they come back to life, and they will breed, these ancient microbes will breed with these new modern ones that you gathered, and they will create immense diversity. It's a good theory, yeah?
How long will salt water stay good?
If you don't get any contaminants in and it's out of the sunlight, it should last forever. I've started up to like 3 years or so. Give it a smell though. If it smells like pilau, it's no good. Like contamination got in there, but it should store a really long time. It should smell like the ocean, like ocean breeze. Yeah. And it lasts a really long time. So if you can't afford salt, you can always go down to the ocean. The dilution of salt is 1 spoon per gallon. The dilution for seawater is 1 to 30. And you're going to add more minerals in this step because your first minerals joined with your leaf material, the microbes already. So you can add more salt in the second step. So your salt was already used up. So these 3 things, what minerals do when you get them into the soil is they'll start to flocculate the soil. So on a chemical level, they'll start to, like, the salts and the minerals will start to bind with the other chemicals, and they'll actually make it like puff up in air. It's kind of like putting tennis balls between plates in clay-like soils. So those minerals help and change how the whole chemical part of your soil is going. And right now, a lot of the topsoil has been pushed off into the ocean. So a lot of those minerals you can bring back from the ocean via seawater or sea salt and put back on your land. And so these three things combined will go into the soil. It'll give everything the microbes need to establish themselves. It'll help to chemically change the soil with the salt. And it won't salt your land too much. It's the same dilution as your blood. So you do need a little bit of salt in there. And these things, they can clean up oil spills. They can clean up radiation. They'll move the particles around. Essentially, what we define as toxins is too much of something concentrated. So what the microbes do to detoxify an environment is they'll go in, and the guys that can handle this harsh environment will work their way towards it, and then they'll disperse and distribute it around so it's less toxic for them. And they work in symbiosis with each other, and they work together, and they'll distribute these things that we consider toxins. They'll cut them, like in the case of oil, they'll cut them into like smaller things, because sugar is just a smaller chain of oil. It's just a hydrocarbon that's shorter. So they'll be able to they see this oil and they're like, well, I want sugar. And they'll cut it into pieces, and all of a sudden now they have sugar to eat. And so they will change these compounds in place, in situ, in the ground. And what to us is now is toxic concentration, they will go in and they will disperse it safely. And they do that in tandem with plants and other things that help them to get the carbon structures to store them where they need them. But more than anything, getting the life in there, giving them food so they can go to work, and giving them the minerals they need, which is kind of like their armor that they put on. Giving them what they need to go into battle for us will let them clean up our environment. And all of these things that I mentioned here cost you whatever it costs you for the bucket, right? And a potato. And everything else, it's just walking. So super affordable. I just got a pretty gnarly power sprayer to go and to be able to shoot this stuff on a large area. So far I haven't found that putting the microbes under high pressure has been detrimental to them. They still seem to work. When I saw it in Korea, they were using pressure washers to spray this stuff out. So I know they can handle pretty high pressure. It's more when you're spraying something, it's not the actual shooting out of the thing, it's when it hits something. So if I'm taking it and I'm shooting it straight at a rock, I'm gonna kill most of the microbes. But if I have a fine mist and I'm spraying it, it's gonna work pretty well. That's, from my understanding, that's what I know. Yes?
So the plastics in the ocean are handled pretty easily by the microbes?
I would think so. I mean, it's so all that stuff, all that oil that we put out there, it all has to go back through biology to then be stored again. So something is going to have to eat it. And better the microbes eat it that are going to be able to transmute it safely than larger life forms eat it and it accumulates and then we eat it. But all this oil that we've dug up from the ground, all this stuff, it has to go back through biology to be back into a carbon form, to be back stored in the earth. It has to, so we get that job.
I was wondering if it's them that are doing it, or fungus. I mean, if it's microorganisms, is it all bacteria?
No, so I've studied this really in a lot of depth, whether it's fungus or bacteria. What I've really come to conclude is it doesn't matter. If you use it and it works, it works. This recipe I know works. It's super simple. To go back later and to understand which process and what's happening. But the way microbes work, I mean, this one will decompose it a little ways, and then that one will eat that one, and this one will eat those ones. And and their amount of chains and how complex it is and what's going on is, it's unfathomable. But there are other natural farming recipes where you can specifically breed beneficial fungus, and for establishing forest types of things, that beneficial fungus is hugely beneficial to you. But for just general cleaning things up, your main ally is diversity. The more diversity you can get in here, the better, because this guy likes that guy likes that, and if they're able to work together, diversity is the key here.
So then like all the nematodes and the protozoa and the needles are going to go through the salt and they'll survive in that salt water. But they'll come along, I'm sure, at some point.
Yeah, if you let it go, yeah, and it can get really technical in answering that.
I'm just curious, I want to see how all that pollution is actually getting eaten. I'm skeptical that it is.
So mostly bacteria, fungus, and yeasts are going to do most that type of decomposition, and then a thing like protozoa is going to come in and eat those and help that system to cycle.
Cool.
Yeah.
Can't wait to see it next.
Yeah. Any other questions?
I got a couple of things. One of them, they kind of help answer your question, Alzheimer's experiment.
Yeah.
You did that experiment with mushrooms, basically eating the oil.
Yeah, it's oyster mushroom.
Right. And then the other thing, to create the right diversity for a particular plant, so if you're going for a coffee or something, you can just take the leaf litter and the material from a healthy plant. That's the diversity you're looking for in a chain reaction.
Yep.
And then bam, you got your ecosystem.
Yeah. So when you're trying to do plants, getting it from the same healthy plant of the same type you want to grow, using mushrooms are very good. But for general cleaning up the earth, I'm thinking if everyone here had a sprayer and we all started spraying the roadsides after they spray Roundup, we could immediately restore that biodiversity, get the whole system going. That stuff then isn't going to run into the water. It's actually going to be eaten up there. Anywhere and everywhere, because so often I'll address farmers that just want to do a farm, but it's man, we need to be spraying this everywhere right now. Really, when they talk about climate change, it's because our microbes are dying like crazy, and that's destabilizing our environment. But as we reestablish this ecology into the soil and we reestablish this diversity, it then restores that homeostasis that diversity is able to maintain.
Have you researched our biochar as well?
And the second best thing you can include with this, I didn't mention it because it wasn't ultra low cost, is to throw biochar in those areas. Because like I said, the microbes have interactions with plants to get the carbon to store these things. Carbon is basically a maximum security prison that they'll bring different elements. If it's not already saturated, if the prison's not full, they will bring those elements and store them in there if they're dangerous. So if you can take a huge thing of a super max prison, which is biochar, and put it out there, they will take those toxins and transport a whole bunch in there. Tons of solitary confinement.
Did the rapid get that thing back to you about it? Did you send the sample to them?
No, the PBARC lab has not corresponded with us in a serious way, but we have done homebrew tests, and so Rapidohea is killing the forest with this exact solution we're talking about here, spraying it on trees and new shoots coming out. So bringing things back to life even. That's why I say you can reverse climate change. We can reverse this environmental degradation that everyone else is just ready to accept. We can actually turn the tides, and for ultra low cost, change, Yeah.
I just want to share that because we have lots of water catchment in our island, but I know people using the Clorox in there, bleach in there. If you want to make the living water, you just add a liquid ammo 4, and then it became a living water. You don't have to use any of those. I've been using them about 6 years now. Water doesn't have a bad smell, but yeah, so you don't have no allergy, and yeah, just try that. And also it will help your environment because it has a runoff, right? So when it rains, with all these microorganisms, liquefied water just shoot out to your backyard, and then you can add sometimes water salt calcium. But after heavy rain, your plant needs calcium to hold their body and the repair. Also, you can put in some lactic acid bacteria too, but do not put too much because they are very delicate. So if you have 10,000 gallons of water, you probably need maybe 200 milliliter. That's all I require. So maybe you put in once a year. Yeah. If your water is just has so much rain it goes out, then maybe twice a year. It's guaranteed. It's so easy solution. It's like Drake said, you can make a living water with microorganisms.
Yes. So yeah, tonight the living water super vital. But I'm really, the more of us that get into this and start practicing and start doing it, start getting the microbes out. It's really important. They're kind of the bedrock. I mean, every person has their different solution, but I believe that this is one of the root solutions. Most other solutions are built upon microbes, and somehow, people talk about hemp bioremediating areas. I believe the microbes that go in the roots of the hemp are actually really beneficial, and somehow it's the microbes that are actually doing this action, because the hemp plant doesn't actually take up all the toxins. They somehow disappear. But what it is, it's the microbes moving them with different carbon structures to make them safe and moving them throughout. So there's tons of solutions, tons of ways to bioremediate the land, but this is by far the cheapest. Get fire trucks that are spraying this stuff out, and we can bioremediate acres and acres. So, thank you. So, thanks for coming out tonight.